All right, so we're going to talk about segment lengths in circles. And so I kind of want to refresh you about the different type of segments in a circle. So first there's a secant, which is a line that intersects a circle in two places. So this is an example of a secant. Then we have a tangent. And a tangent is a line that intersects a circle at exactly one point. And so here will be an example of a tangent. And then lastly, we're going to talk about a chord, and a chord is a segment with endpoints on the circle. Okay. All right, so now we want to talk about how to find the different lengths of segments in a circle. So if you have two tangents from the same external point, so in this case you have two tangents, which are AB and BC, and they're tangents to circle D, then we know that those two tangents are congruent to each other. So this is congruent to this, so we can always just set them equal to each other. Okay. Then we have intersecting chords or secants on the interior of a circle. And so to find the missing segment lengths, where the two chords are cut, each piece of the chord, if you multiply them, will be equal to the product of the other two pieces of the other chord multiplied. So in this case, A times B is going to be equal to C times D. And then we have intersectant secants. And in this case, we're going to take the outside times the outside plus the inside, and that's going to be equal to the outside times the outside plus the inside of the other secant. And then if you have a tangent and a secant that intersect on the exterior, then the tangent, the outside piece that's only on the outside, we square that, and that's equal to the outside times the outside plus the inside. So we're going to do a few practice problems just with the different rules with the segments. Now these are not on your formula sheet, so these are ones that you're going to have to memorize how to do. All right, so example 1, we actually have two tangents. And the two tangents, remember, they have to be equal to each other. So that means we can set these two equal to each other. So we can do 8x minus 19 is equal to 5x plus 23. And so now if we need to find x, we just need to solve this for x. So we're going to subtract 5x from both sides. And so we end up with 3x minus 19 is equal to 23. Add 19 to both sides. And we end up with 3x equals 42. And then divide by 3, you get x is 14. And so since this question is just asking for x, we are done. Now if we needed to find a, b, or bc, we would just take x and plug it in. Okay? Alright, so look at example 2. In example 2, we're not just trying to find x, we're trying to find PQ. These are still two tangents. So I want you to pause the video very quickly, and then you go ahead and try to work this out, making sure you actually answer the question. So hopefully you worked this out. You saw that the tangents should have been equal to each other, so we set them equal to each other and solved for x. And we got x is 3, but then because they wanted PQ, we just plug it in, and we find that PQ is equal to 29. Okay. Okay, so let's look at example 3. In example 3, we actually have the two intersecting chords. So remember, the pieces of the chords multiplied together are equal to the product of the other pieces of the other chord. So in this case, 10 times x is going to be equal to 14 times 15. And so now we have 10x is equal to 210. And then so we can divide both sides by 10. Oops. and we get x is equal to 21. And since we're only trying to find x, there we go, we have our answer. X is equal to 21. Alright, so let's look at example 4. So again, we still have intersecting chords here, and they want us to find BD. So make sure you know we're going to have to plug something in at the end. But we're just going to go ahead and get started and just see that this has an expression there. So we need to still multiply the pieces, but remember you got to set this up as to look like distribution. So you can multiply them and then equals the 6 times 6. So we're going to go ahead and distribute here. Remember when you distribute, you got to distribute to both terms in parentheses. So it's 20x minus 4 is equal to 36. Add 4 to both sides. We get 20x is equal to 40. And then we divide both sides by 20. And we get x is equal to 2. So if we just wanted to find x, we'd be done, but we need to find BD. So BD is the entire segment. So we know BD is really the 4 plus the 5x minus 1. So we got to add them all together. So that's 4 plus 5 times 2 minus 1. So we get 4 plus 10 minus 1. And we do all that together, we end up with BD is equal to 13. Okay? So make sure if they're asking for the whole segment that you add both pieces to get the entire segment. Alright, let's do the next example. Example 5 here, we want to solve for x. In this case, we have two expressions, but still we're going to just distribute. So we got the 27 times the x plus 5. So remember that's going to go in parentheses. And that's going to be equal to the 24 times x plus 7. Oops. Let's see what's going on here. Let's get our pen back. For some reason my pen doesn't want to work. Alright, so once we get this, we're just going to distribute here. So we'll get 27x plus 135 is equal to 24x plus 168. Subtract the 24x from both sides. We're going to get 3x plus 135 is equal to 168. And then subtract the 135 from both sides. So we get 3x equals 33. And so now x is equal to 11. Oops. Cancel. And that's what we're looking for. Okay. Alright, so what I want you to do is pause the video and you try number 6. Make sure you know that you're trying to find TQ. Okay, so pause the video and see what you come up with. Alright, so working this out, you should have found that TQ was 27. You should have been able to multiply the pieces of each chord together, and then solving at x is 13, and then be able to plug that in and get TQ is 27. Alright, let's look at example 7. These are examples of intersecting secants. So in here we want to solve for x. So remember that's the outside, which is 8, times the outside plus the inside. And that's equal to the outside on the other one times the outside plus the inside. Okay, so now I'm going to just simplify this. And so 8 plus 19 is 27. And then I'm going to distribute here. So 9 times 9 is 81 plus 9x. I'm going to finish simplifying here. 8 times 27 is 216 equals 81 plus 9x. So again, we just have our equations to solve. Let's subtract 81 from each side. We end up with 135 is equal to 9x. Divide both sides by 9 and you get 15 is equal to x. So here's our final answer. Okay. So let's look at example 8. Go ahead and pause your video. I want you to go ahead and try that. Just make sure you realize you need to find NL. So go ahead and pause your video and see what you guys can come up with. Alright, so here we know that NL is equal to 40. So we go ahead and did the outside times the outside plus the inside and set those equal to each other. We should have gotten that x was 27. And now we plug in 27 because NL is the entire segment, the 13 and the x. So we add those together and we end up with 40. Alright, let's try example number 9. Still going to do the outside times the outside plus the inside. And that's equal to, again, the outside times the outside plus the inside. Now I like to go ahead and combine like terms in here. So we get 12 plus 3x is equal to 7 times 9 plus 5x. And then I would go ahead and distribute. So I have 96 plus 24x equals 63 plus 35x. Now we're just going to solve for x by subtracting 24x from both sides. So we have 96 equals 63 plus 11x. I'm going to subtract 63 from both sides. I'll wind up with 33 is equal to 11x. Divide by 11. 3 is equal to x. And that's what we're looking for. So we're done. Okay. So I want you to go ahead and pause the video and try number 10. Also remember, pay attention to what you're looking for. So go ahead and pause the video and see what you come up with. So for example 10, yz is equal to 9. And went ahead and did the outside times the outside plus the inside and set them equal to each other. Got x is 10. Plug it in. Yz is only this section, the x minus 1. So 10 minus 1 is 9. Alright, let's do 11, which are examples of a tangent and a secant. So we're going to take this outside portion, make it 24 squared is equal to, and then we're going to do the same thing. We've been doing the outside times the outside plus the inside. And then so we know that 24 squared is 576. And then we're going to distribute here, which you get 324 plus 18x. Subtract 324 from both sides. Divide both sides by 18. We get 14 equals x. And since we're looking for x, oops, don't turn it. That's what we got. So here's our answer. Alright, so go ahead and pause the video. I want you to go ahead and try to find Pn. Make sure you know what you're looking for. So here you should have gotten that Pn is equal to 24. Again, here's all my work where we should have got x is equal to 5. And then just go ahead and plug in 5 for 5x minus 1. And we end up with Pn is equal to 24. Okay, so these are all the examples. We are done. Good job, everybody.